Hi, boys and girls. Welcome to Module 1, Lesson 3, Tables of Proportional Relationships. I am not running camera today because my computer was going so incredibly slow that the lag was awful. So we're not going to use that today. I'm just going to show you the flip charts. Okay, so this begins in your book on page 21. Okay, the vocabulary you will learn, the constant of proportionality. We're going to use that word a lot. Non-proportional and proportional, we already have been using those. Your I can statement is right here, and it's on every page. I can determine whether two quantities shown in a table are in a proportional relationship by testing for equivalent ratios. Next. Two quantities are proportional if the ratios comparing them are equivalent. In the table, all of the ratios comparing the cost to the number of pizzas are equivalent and have a unit rate of $7 for one pizza. So the cost of the order is proportional to the number of pizzas ordered. Okay, so you'll notice that you can take each of these top numbers and multiply them by 7 to get the cost for pizzas because every pizza is $7. Okay. And then the constant of proportionality is actually the 7. It's what number you multiply the top number with to get the bottom number. All right, so if you multiply 1 times 7, you get 7. 2 times 7, you get 14. The constant of proportionality is always 7. Now, this is an example where the ratios are not proportional. Okay, they're charging $9 for one pizza, but only $8 if you buy two pizzas. So you charge $8 per pizza. Okay. Because these numbers are not the same, this is not proportional. Okay. Moving on. Example number 1, proportional relationships and tables. Carrie earns $8.50 per hour babysitting. Is the amount of money she earns proportional to the number of hours she spends babysitting? Well, yes, this is always going to be the case because she charges $8.50 for every hour. So after 1 hour, she gets $8.50. After 2 hours, let me change the size on this because I'm missing part of the problem down here. Nope, this part. All righty, there we go. Now I got it all on here. Squeeze it all on the screen. Okay, so for 2 hours of babysitting, she would get $17. For 3 hours of babysitting, she would get $25.50. I'm not doing this in my head, it's all down here. And for 4 hours, she would get $34. Okay? And you'll notice that if you write each of these as a ratio with this number over this number, the amount of money she earns per hour, because you would say money per hour, so money goes on top, even though it's on the bottom in the chart. Money per hour, $8.50 an hour. $25.50 for 3 hours is equal to $8.50 for 1 hour. Because these are all equal to $8.50 for 1 hour, this is proportional. An adult elephant drinks about 225 liters of water each day. Is the amount of water proportional to the number of days that have passed? So you write each of these, water per day. This is what we want them all to be equal to if it's proportional. So then we would have 450 liters for 2 days. Well, to make this over 1, you would do 450 divided by 2. 450 divided by 2 is 225. Then we would take 675 over 3 and would change it to a unit rate. So over 1, 675 divided by 3 is, you guessed it, 225. And the same for 900. And 4, if we put that as a unit rate, is also 225. So because these are all equal to the same fraction, the ratios are proportional, and that makes the table proportional. Okay, so now here we have a ticket agency is charging a $6 service fee on any order, and each ticket is $25. Now the $6 service fee is going to make this so it's not proportional. What's going to happen is no matter how many tickets you buy, you only pay the one $6 fee. So this is not going to be proportional. If the unit rate is one ticket is $31 because you pay the $6 plus the $25 for the ticket. But then when you get to 2 people, you only still paying one of the $6, and then 2 of the $25. Okay, so what happens here is this ends up being not proportional. Like, see, for example, down here, this is 31 over 3, but this one works out to 28 over 1. And then 81 divided by 3. Oh, you don't want to see me do long division. Give me a calculator. 81 divided by 3 is 27. And then 106 divided by 4 is 2650. Okay, so this table is not proportional because these are not all equal to the same unit rate. The unit rate's different for each ticket sales. Okay, so here's our check. The table shows how long it took Maria to run laps around the school track. Is the number of laps she ran proportional to the time it took her? So we're going to have 3 rates here. We have 150 over 2. We have 320 over 4 and 580 over 6. And in each case, we want to write these as a unit rate so that we can see if the unit rates are all equal. Well, this one is 75. So it took her 75 seconds to run 1 lap. Is 325 divided by 4 also 75? I will tell you in just a second. No, it's not. It's equal to 80. And then 580 divided by 6 is 96.6 repeating. So this is not proportional because these unit rates are not the same. If these unit rates were the same, it would be proportional. Because they're not the same, it's not proportional. All right, so in each case, the constant of proportionality is what we're actually finding, all right? The constant of proportionality is what would you multiply this number with to get this one? Remember in the pizza example at the beginning, the constant of proportionality was 7, because no matter how many pizzas you ordered, you would multiply that number times 7, okay? So they're asking us for the constant of proportionality here. Well, you're always looking for where the unit rate is, because for 1 second is 24 frames. So each of these is going to reduce to 24 over 1 frames per second. This one is also equal to 24 over 1 if you reduce that fraction. So the constant of proportionality is 24, and the unit rate is 24 frames per second. Messy handwriting. Okay, and actually that information is down here too. Okay. So that's proportional. Identify the constant of proportionality. Okay, so the winner of a jump rope competition jumped 124 times in 20 seconds and 186 times in 30 seconds. So what you got to do is you want to find the constant of proportionality. You want to find what is it equal to if the bottom number is 1. What's the unit rate? The unit rate is your constant of proportionality. So here we did 124 jumps in 20 seconds. And we want to know how many jumps that is in 1 second. All right, so when you do 124 divided by 20, you get 6.2. Here we had 186 jumps in 30 seconds. 186 divided by 30 is also 6.2. So the constant of proportionality is 6.2. Okay? That's the number you multiply with. You know, no matter how many seconds, you multiply it times 6.2 and you get the number of jumps. Okay, on page 25, the cost of a birthday party at a skating rink is proportional to the number of guests. The skating rink charges $82.50 for 10 guests. So the choices show the number of guests and the total cost for 4 different parties that were hosted at different locations. Select each party that was hosted with the same constant of proportionality or unit rate as a skating rink's unit rate. Well, the skating rink is telling us that they're charging $82.50 for 10 guests. So let's make this a unit rate. Let's find the constant of proportionality. What is $82.50 divided by 10? Well, it's $8.25. So for one person, that's what the skating rink is charging, $8.25 for one person. So you come over here and you're challenged to take the price and divide it by 12 to see, is this equal to this? Do we get the same answer? You would do 99 divided by 12, right? 99 divided by 12 is 825. So because this is equal to 825 over 1, we check that box. 52 divided by 8 is 650. So this one is not going to be checked. It has to be 825. This one, 9750 divided by 15 guests, is charging 650, cheaper than the skating rink. And this one down here, 4950 divided by 6, is 825 per guest. So you would mark the top one and the bottom one. Example 4, identify the constant of proportionality. After a volcanic eruption, lava flows down the slopes of the volcano. The distance the lava flows is proportional to the time. So they're already telling you this is proportional, okay? So we know that there's some number that we're multiplying this one with to get this one. But we want to find it. For each time, find the ratio, number of meters over number of seconds, and rewrite it with the denominator of 1. So we did 9 meters in 5 seconds. All right, so 9 divided by 5 is 1.8. Now you could go ahead and cheat because they've already told you this is proportional. So that tells me that no matter what, all of these are going to have the same solution. They're all going to be 1.8. This one I can do in my head because anything divided by 10 moves the decimal one place. 27 divided by 15 is, guess what, 1.8. And I think we all know where this is going. 36 divided by 20 is, yes indeed, 1.8. So the constant of proportionality is 1.8. All right. If you took 1.8 and multiplied it times each of these numbers, you get this number. Multiply this one times 1.8, you get this one. Multiply this one times 1.8, you get this one. And multiply this one times 1.8, you get this one. That's why 1.8 is the constant of proportionality. Okay, so we have 3 friends earning money during a bake sale, okay? And they're getting paid by the hour. Now, in the first example here, Allie, they have given you the constant of proportionality or the unit rate. It's 17, okay? Because they've given you 1 hour, all right? They saved you some time there. So, Allie is making $17 for 1 hour. But they haven't been so kind with the other 2. So in these cases, you're going to want to take the $9 and divide it by 0.75. Okay. Well, this one is, but your basic long division. I'll go ahead and do one of these, but I'm not going to bore you with too many of them. If we had $9 being divided by 0.75, if you remember from 6th grade, you're not allowed to have a decimal in the number that's outside here. So in order to fix that, you would move this decimal 2 places to the right. Likewise, you have to move this one 2 places to the right. So the real problem we're dividing is 900 divided by 75. Well, 75 goes into 90 one time. 1 times 75 is 75. Subtract, bring down, and 75 goes into 150 2 times. All right, so we now know that Ben is earning $12 per hour. He's not making as much money. Okay. And then we would go down here to 3, and we would do $40 divided by 2.5. And like I said, I'm not going to bore you with that. This isn't how to do long division video. And that one is 16. Okay. So 3 is making $16 for every 1 hour. This is the constant of proportionality for 3. This is the constant of proportionality for Ben. And this is the constant of proportionality for Allie. Okay, so here we have a sales tax then. Jalen went shopping for school clothes. The table shows the sales tax for various purchase amounts. Is the sales tax proportional to the purchase amount? What is the total cost in dollars for a purchase amount of $84? So they're asking us two questions. Is this proportional? And how much tax would we pay if we spent $84? Well, here's what we need to do. You need to take each of these dollars. Well, let me do a word fraction on this one. Let me do a word fraction. We want to know sales tax to the purchase amount. What is the total cost in dollars for a purchase amount of $84? So we're going to be doing sales tax per dollar. Okay. Sales tax per dollar. Sales tax per dollar. And sales tax per dollar. Well, if we do the long division on this one, it would look like this. You would have 0.60 being divided by 12. And we arrive at sales tax is 5 cents on the dollar. Okay, so the unit rate is 5 cents for every dollar you spend. Okay, 5 cents tax for every dollar you spend on clothing. All right, and all of these end up the same answer. 0.05 over 1. You do this number divided by that number. This number divided by that number is 0.05 over 1. And this one divided by this one is 0.05 over 1. So yes, it is proportional. That's our first answer here. But then our second answer is, what if we spent $84? Okay, if we spent $84 and we're paying 5 cents sales tax, we would multiply 84 times 0.05, and that would give us 84 times 0.05 gives us $4.20. So the tax would be $4.20 on an $84 purchase. That's our other answer. Okay. This is a long section, a lot of examples. All right, so here we have the check. It's on page 28. Okay, the table shows 3 membership options at a fitness center. You have the basic one, $20 a class, the Fit Plus, $60 per month plus $10 a class, and the Fit Extreme, $75 a month and a $30 enrollment fee. Logan chooses the membership that represents a proportional relationship between the number of classes and the monthly cost. Which membership did Logan choose? How much will he spend if he takes 12 classes in a month? Okay, so this is another 2-question one. And the first thing they're asking you is, which one has a proportional relationship between the number of classes and the amount it costs you? Well, only the basic membership does this, okay? Because the basic membership doesn't have any additional fees. If you take 1 class, you pay $20. If you take 2 classes, you will pay $40. If you took 3 classes, you would pay $60. Basic membership is the only one that is proportional, okay? All the rest of these have some other fees, okay? How much will he spend if he takes 12 classes in a month? Well, it's $20 per class, so what's $20 times 12? Okay. Well, that would be $240. So that's the second answer. And I want to say, I think that's the last example before we get to the practice problems. Yep, that's the last example. So that's the end of this video. You guys can watch it again if you missed something, or if you just like torturing yourself with math videos. That's up to you. You can do that. And this is Mrs. Williamson trying to figure out how to sign off from here. Oh, there we have it. All right, you guys have a great rest of your day.